Para mí un gran honor presentar al primer ponente de este encuentro, el profesor Harold Kroto, Premio Nobel de Química del año 1996. Nació en un pueblecito del sureste del Reino Unido en 1939. En 1958 ingresa en la Universidad de Sheffield, donde se graduó en Química y allí realizó su tesis doctoral. Durante estos años en la universidad compaginó la química con dos grandes aficiones: el tenis, formó parte del equipo de tenis de la universidad, y el diseño gráfico. Al finalizar la tesis se incorpora al Consejo Nacional de Investigación en Canadá, donde estaba Herzberg, Premio Nobel de Química en el 71, que juntos con otros colegas habían puesto en marcha un centro de referencia a nivel mundial en el ámbito de la espectroscopía. En 1985 vuelve de catedrático a la Universidad de Sussex y, realizando experimentos que trataban de explicar la abundancia de cadenas largas de carbono en el espacio interestelar, realiza el descubrimiento del C60 o el fullereno o el Buckminster fullereno, junto con Heath, O'Brien, Cole y Smiley. Con estos dos últimos comparte el Premio Nobel de Química. Lo negativo del descubrimiento para él fue que tuvo que aparcar definitivamente su gran sueño de montar un estudio de diseño gráfico, faceta que había seguido practicando casi semiprofesionalmente. En 1991 accede a una cátedra de la Royal Research Society que le permite centrarse casi por completo en la investigación, aunque sin renunciar totalmente a la docencia y a la divulgación, otra de sus grandes pasiones. En este sentido, en 1995, colaborando con la BBC, funda el Vega Science Trust para la producción de películas científicas de alta calidad y que en la actualidad da acceso libre a través de Internet a numerosos vídeos de ciencia. Estas películas no solo reflejan la excitación y la pasión del descubrimiento científico, sino también los conceptos intrínsecos y principios sin los cuales la comprensión sería imposible. I will say that in English. These films that I have enjoyed not only reflect the excitement of scientific discovery, but also the intrinsic concepts and principles without which fundamental understanding is impossible. Desde 2004 es titular de la Cátedra de Química Francis Epes en la Florida State University. Su trabajo investigador se centra en los conocimientos de los componentes moleculares del carbono, la estabilización de fullerenos y los nanotubos. Pero asimismo lidera un proyecto muy importante también para nosotros, el proyecto GEOSET, Global Strategic Outreach Science, Engineering and Technology, dedicado a la creación y difusión de material docente de alta calidad en los campos de las ciencias, la ingeniería y la tecnología, y creado por los mejores científicos y tecnólogos. Y en esta charla que inaugura este congreso nos hablará precisamente de la importancia de la educación en ciencia y en tecnología, la importancia que éstas deben tener para la consecución de un modelo de desarrollo realmente sostenible para la humanidad. We are very proud and very grateful to have you here. Thank you very much, sir.
My pleasure. No, take it away. Take it away. Okay. Well, thank you very much for that very nice introduction. It's a pleasure to be here back in Spain and for the first time in San Sebastian. I'm going to talk about issues that I think are important for me, and hopefully you will appreciate that they're important for you as well. They're about science, society, and sustainability. I'll start this particular talk with my favorite quotation from Don Marquis. If you make people think they're thinking, they love you. But if you really make them think, they hate you. I hope you haven't all left by the end of my talk. But if you have, then I've at least made you think. Now, I thought I'd tell you how I got here. At school, I wanted to be Superman. And this is a picture of me. But I found it was rather difficult to fly. And man's got to know his limitations. And you've got films here. So I played tennis, and I did gymnastics. And also I acted in Henry V at school. Now, I thought I'd show you this picture because I'll show you these two guys. I'm the handsome guy on the right here. I usually tell young people that they should really be scientists because the guy on the left, he remained an actor. and he got old very quickly. Now, I thought I'd just show you that basically he, I guess, must have been here last week. Is that right? And he had the same shirt on as I've got on. But unfortunately, I have to perform live. He gets it all the mistakes edited out. However, Ian McKellen and I were in the same year at school. Fantastic actor, and I'm sure you enjoyed his performances. But I'm much younger than he is. But here's Ian in Magneto and in the X-Men. Okay, so basically I ended up in science. But one reason is that I had Meccano. I don't know how many of you had Meccano or something like it. Oh, yes. Well, my world was made of nuts and bolts, and I made things like this. And I thought I'd show you this advertisement. Meccano boys and girls are keen, ambitious, and inventive. No boy or girl who follows the Meccano hobby can be a bad boy or, unfortunately, bad girl. But in fact, my world was made of nuts and bolts, and my world today is made of the nuts and bolts, electrons and atoms that make materials. So there's a great similarity there. The other thing, which I think was important to me, was photography. And I thought I'd show you my camera. And many of you who are older than 500 years old will remember this time when we had film like this, loaded the film in the dark, knew what the exposure time was, F numbers, closed the iris, unloaded it in the dark, put it on a spool, put the chemicals in, dried it up, put it in a printing frame, developed it and fixed it, hung it out to dry, and this is a picture of me done that way when I was 17. But today, Kodak changed a little bit, made things a bit better. In fact, I took this picture in Stockholm, a 90-second exposure, handheld, actually. But today, that's all it is. And I think it's important to realize that. Now, we should have some sound, and there's no sound, so can I have some sound next time? Can we make sure there's sound? Just to check it out? Okay, some sound. I'll need it later. The other thing that was important to me was graphics. My main passion is art and graphics. Oops, Daisy, that should have gone back. And I thought I'd show you this. It seems to be that hyperlink moved. And I did do a lot of drawing. And I think there's a relationship between drawing and art and the sciences. They're to do with patterns. And so I painted. I did this for a buckyball workshop in Australia. And these were posters on the underground. And this design was for my first national award. It was not for science, but it was for this particular design for the Sunday Times. And this is what I used to look like. And there are young people in the audience who will look as old and decrepit as I do one day. So if you're young and beautiful now, it won't last. I also drew this, which is Stockholm Town Hall, where the Nobel Prize was awarded. And this is a drawing I did at school. I only got good for my frog, but I used to get very good for my maths and science. So I ended up in the sciences. So what is science? Well, this is a picture of Bronowski with his grandchild. And the little boy is putting the cube through the square hole. And there was one little boy who shall be nameless. Every time he took the cube, he tried to put it through the round hole. It didn't matter what shape it was, it went through the round hole, or he tried to get it through there. His mother realized that this was a big problem, went to see a psychiatrist. The psychiatrist said, "Don't worry. This kid only sees one solution, whatever the problem is, and there's a perfect career for a child like that, and that's to be a politician." Mrs. Blair. Okay, so there we have it. But science is well encapsulated by my colleague, Capricornforth. A picture taken of him when he was about 18, when he realized he was going to be deaf for the rest of his life. But he overcame all that to become a Nobel Prize winner. And I used to think you had to be as smart as this guy to get the Nobel Prize. I now know it's not necessary. You can be as dumb as I am and get it. Okay. Kappa goes on to say it may seem odd that a system of knowledge based on doubt could have been the driving force constructing modern civilization. Scientists do not believe, they check. I'm not asking you to believe anything I say on a scientific matter, only that there is tested evidence for all of it, and I know the nature of that evidence and can make a judgment of its worth. That's what science is about. In fact, we should be able to take, in the future, a whole supercomputer and put it into a wristwatch. This is a Calvin Klein wristwatch. Because he put CK on it, you pay 10 times what it's worth. You put HK on it and nobody will give you anything for it. This is my initials. We should be able to look at these and recognize that the 21st century is the century of molecular machines. Now, what are molecular machines? Well, this is nitrosoethane. This is my favorite molecule, really. It's a space-filling molecule, and it's my dog. It's made of carbon, hydrogen, it's got nitrogen, oxygen. And I look at this, and I can show that the dog shakes its head and looks at its tail. So what is it? Well, let's look at this dog, because it's been drinking, and sometimes things go a bit wobbly. It gets a red nose, and if you've been drinking and you're a dog, you know what the problem is. And if you see a lamppost, it's very useful because you can actually use it. Okay. Now, molecules do this, all right? They're flexible. And when I saw ATP synthase for the first time, this fantastic molecule, it's a molecular machine. It's nanotechnology. When one talks about nanotechnology, this molecule is in your body turning by electrons. In fact, protons are going on here, neutralizing a negative charge on this wheel as it rotates. A spindle in here opens and shuts these cavities. ADP goes in and ATP comes out. This is going on inside your body at the present time. It's an amazing machine. Had I seen this when I was young, I would have moved into this area, definitely. Genetic engineering, people think it's new. It's not at all new. Over thousands of years, this animal has been made by human genetically engineering it into a chihuahua, okay? With DNA, we can probably make a human being into a chihuahua. And there are some human beings that I suggest we do that too. But a good definition of nanoscience and nanotechnology is atom by atom, molecule by molecule assembly of a complex or functional system. And so the best example of nanotechnology and nanoscience, atom by atom, molecule by molecule assembly, is us. So if you don't like nanotechnology, you should dump in the river, okay? Because you are the results of nanoscience and nanotechnology. 21st century science is nanotechnology. It's a 21st century perspective. And what is it? Well, physics, biology, and engineering are pulled in to chemistry as never before. It's a very exciting time, and we must recognize it. Not only that, it's international. Spanish, British, Irish, Syrian, Holland, Dutch, Taiwanese, Mexicans, and Indians. These are the students who worked with us, and it's international. Science is different from all the others because we speak a common language of science. We're independent of what's in our head, what color we are, what religion we are, what nationality there is. The only room for, I think, being nationalistic is when Rafa's playing tennis versus Murray in Britain. No other things are necessary. And so we are here at this meeting. And Pedro, fantastic meeting. It's very important to realize what the problems are. And so, atom by atom, molecule by molecule assembly. That's what we're trying to do, okay? It's happened before, life has done it, we're trying to do it ourselves. But it's a problem. Now then, why do I show this? The desire to fund science that is clearly predictable to be in the public interest is, on the face of it, an excellent motive. Unfortunately, it overlooks the most crucial aspect of science. It's totally unexpected. This molecule came from left field. We didn't know it was there. It was totally unpredictable. In 1970, applied science in the UK received about 85% of the total research budget for science, and about 15% went to fundamental science. Public and politicians tend only to understand science in terms of its value to society, i.e., strategically. This is quite understandable. However, this results in a major problem. By introducing so-called strategic initiatives, Mrs. Thatcher cut the UK fundamental science budget by about a half and diverted 7.5% to applied science. Now, 7.5% plus 85% made peanuts worth of difference, okay? It was not worth little impact. But it was catastrophic as far as fundamental science is concerned by cutting it 50%. It became below the threshold of viability. Politicians must recognize that. The fullerenes, the reason I'm here, it was discovered because we wanted to understand the chemistry in carbon stars, astrophysics, not in combustion flames. There are maybe 100 to 500 combustion labs in the world. None of them predicted that C60 would be in a flame, and yet it's made commercially now at Mitsubishi by combustion. In fact, the most violent and abusive attacks on our claim to have discovered C60 came from the combustion research community. That's the issue that we face. History has shown time and time again that the paradigm-shifting sciences invariably result from an intrinsically creative and intellectual attitude, puzzled, not knowing where we're going, not a strategic one, just as in the case of the arts. Great science is unpredictable. Not my fault, just the way it is. But few people outside the sciences accept it. I'm going to come to the more serious issues about science. Bertrand Russell said, and it's, I think, my favorite philosopher, not that I have many philosophers who are my favorites. I mean by intellectual integrity the habit of deciding vexed questions in accordance with the evidence or leaving them undecided where the evidence is inconclusive. The essence of the liberal outlook lies not in what opinions are held, but in how they are held. Instead of being held dogmatically, they're held tentatively, and with consciousness that new evidence may at any moment lead to their abandonment. This is the way opinions are held in science, as opposed to the way they're held in theology. He also made another one. It's quite now lawful for Catholic women to avoid pregnancy by resort to mathematics, though she's forbidden to resort to physics or chemistry. Interesting point. Okay. J.B.S. Haldane, a very famous British scientist, said, "My practice as a scientist is atheistic. That is to say, when I set up an experiment, I assume that no God, angel, or devil is going to interfere with its course. And this assumption has been justified by such success as I have achieved in my professional career. I should therefore be intellectually dishonest if I were not also atheistic in affairs of the world." Dr. Haldane, a journalist I think asked, "In the unlikely event that there is a God, what would you have to say?" He said, "Well, he shows an inordinate fondness for beetles. There are 350,000 different species." Okay, that's an interesting point. Okay, my view of science is rather different from others, and it goes back to this question, which is, I seek not the answer, but to understand the question. It's an interesting philosophical point about science. And I wanted to know where it came from. So I went to Google, and I looked, and it turned out it was me. Wherever I looked, it was there. But if I changed it slightly to know the answers and the questions, it turned out it was Kung Fu, all right? And it was Confucius, who I believe today, according to Google, it's Confucius's birthday. So one up for Confucius, all right? He was a clever guy. I developed a 4 out of 5 rule, my rule of science. And it's my scientific method, my 4 out of 5 rule. If you make an observation, develop a theory that you think explains it. Then design some further experiments to test the validity of the theory. If 4 observations out of 5 fit, you're almost certainly right. And the main important is almost. If only 1 out of 5 fits, you're almost certainly wrong. Again, almost, most times. Now, there are 3 senses, it seemed to me. What do I mean by that? Well, Aristotle's universe was that basically common sense. It's obvious. The sun goes round the earth. Watch it every day, doesn't it? It's common sense. You don't need to know what uncommon sense tells you, and that it's the earth turning on its axis. Okay? That is uncommon sense. That's science. Copernicus and Galileo, they had uncommon sense. And we have to be careful because it may take centuries to dispel false beliefs. In fact, it took till 1992 for the Vatican to agree that Galileo was indeed right. It may take 1,000 years for America to accept that Darwin was right. They're having a problem at the present time, as I'll show you. The trouble is nonsense is common. Why do I say that? Well, let's look at a $27 million museum just outside Cincinnati. Young children are being taken into this museum. Busloads are going to it. It's full. They're told that the Grand Canyon was carved by Noah's flood 5,000 years ago. And Noah, he was a Scot. He's got a Scottish accent. He said, we've got to build a big boat because there's a big flood coming. Okay. Humans, did they live with dinosaurs? God made Adam and Eve on the same day as the land animals, so dinosaurs and people lived at the same time. If that's so, we clearly must have put saddles on them and ridden the damn things, okay? What did dinosaurs originally eat? Well, before Adam sinned, all animals, including dinosaurs, were vegetarian. Well, dig those dentures. I mean, those are not vegetarian teeth, okay? What happened to the dinosaurs that didn't get into Noah's Ark? Well, they were drowned in the flood 4,350 years ago, and many were buried and preserved as fossils. So no wonder this little girl is scratching her head. That's the problem. And it's a big one in the States. Yet we learn from countless observations that our genes, he's got 98% of the same genes as us, maybe 91. I love this guy. Look at the face. There's a humanity in that face. I love the fact that I'm a close relative of this guy. I love this guy too. He's another cousin. Fruit flies, 50% of our genes are the same. We're related to fruit flies and the maggots of fruit flies, okay? And 70% the same as pumpkins. That's fantastic. I just love the fact that I'm related to a pumpkin. In some cases, it's pretty obvious as well. I think the problem that we face at the present time is what I call indoctrination. And I'm disturbed about it. This is Christian Play School. This is a madrasa, 17,000 madrasas teaching young children as young as 2, 3, and 4, nothing but the Quran. In Israel, also separating these children. These are Muslim children, Jewish children. I could have been one of these kids on the right-hand side. My parents were refugees from Central Europe, from Berlin, and previously that to this area where this picture was taken. The question we should ask ourselves, have parents the right to bring up children as they want? It's an interesting question. Most people would say yes. I would have said yes. But should parents have the right to teach their children that their classmates will go to hell because they are of a different religion from them, or no religion? It's an interesting point. That is being taught in British schools at the present time with British taxpayers' money. Northern Ireland is a very good example of that problem. This is an ad that I've kept for 30 years from Newsweek. If I were Prime Minister of Northern Ireland, this is how I would solve the problems. First, I would split Northern Ireland into two parts, and I would put Protestants on one side and Catholics on the other side. David, I would pass a law saying that any Roman Catholic who set foot on the street to start trouble would be shot instantly and without mercy. I would starve them like rats until there wasn't one left in Northern Ireland. This is not just Northern Ireland today. It's in many parts of the world. I'm sure it's not a lot different in Gaza and in Israel and other places and the other areas. We've got to recognize that our children, we must bring them up differently. I'm sure it's obvious that our children must be taught together. I love this picture, taken in a science workshop with me, probably my favorite picture of these two kids enjoying science. I like this particular little bit of film. It was taken in Mexico when I gave a workshop in Spanish. Not my Spanish, it was translated. Whoops. There you go. Let me go on, because there are workshops all over the world. In Japan, Santa Barbara in California, San Luis Potosi in Mexico, in Malaysia, by internet to Iceland, and also in Australia and also in the UK. This was with Manchester United footballers. I was hoping to have David Beckham. When he learned he had helped me teach the kids algebra, he went off to Real Madrid. Okay, and also the British Association. Sustainability is the crucial issue that most scientists recognize. And there we come to Kappa, my colleague, again. He says in this wonderful article, which I hope you will all look at, Scientists as Citizens, on the vega.org.uk website. A few hundred years ago, a mere breath of time, a concentrated source of energy was discovered in the fossil fuels. Essentially, the energy of old sunlight trapped by life and buried by the earth. Humanity has exploited this resource with all the restraint of a fox in a chicken house. Among non-scientists, there seems to be a general vague expectation, if they think of the matter at all, that science is assured to find some way to rescue future generations from the shit into which the present one. He's an Australian, so he gets away with these words. Okay. Think of this. It took 1 million years to create the fossil fuel that we use in 1 year. We have to increase our efficiency by 10 to the 6, a millionfold. So if you're a scientist, Kappa goes on to say, you realize before long that if the future's in anyone's hands, it's in yours. And so there are scientists working on that problem. We've got to split water. I don't think we can survive the next 100 years without solving this problem. It may be solved by nanotechnology. My favorite animal now is the dung beetle. And you know what it's sitting on? Yes, elephant crap. And if it were no dung beetles, we would be 5,000 feet deep in millions of years of elephant crap. But what are we getting deep in? I'll show you our crap. This is a field in England with 140,000 refrigerators just dumped in the field. It looks bad because they're all in one place. But you know, as you pull all the garbage in the world in one place, you probably would cover much of Spain. Okay? It's a disaster of great proportions. I'm still in graphics, and I do a lot of logos, and so this is my logo for the future. We've got to learn how to actually recycle our own crap. And so we come back to the Kentucky Fried Creation Museum, which looks like this. It asks, why do we suffer? Why am I alone? Is there any hope? Well, there is hope. Let's look at chemistry. I have no doubt that one of the greatest humanitarian contributions that has ever been made was from chemistry of anesthetics. With no mobile phone, look at this amazing drawing of Rowlandson of amputation without anesthetics in the 18th century. Just imagine what chemistry has done and recognize how humanitarian it can be. Penicillin, this is a miracle, okay? A miracle molecule. Blood poisoning in 1942. But fortunately, that year, penicillin became available, and she was cured in 3 weeks. She would have died a year earlier. The future is a problem, because bacteria are evolving with an immunity to antibiotics. We need young people, fantastic, clever young people, who understand evolution, who understand science, to solve these problems, because we are going back to this if we're not very, very careful. Those are the problems. We want to make sure that our children have real heroes. This is the picture in the newspapers of a scientist. Where does it come from? Where does this picture of the mad scientist? We do have this guy, all right? And he's an imposter. He didn't create the theory of relativity or find it or develop it. This totally unknown guy did it. Yeah. Einstein was young. He was 17 when he first started to think about this problem. But children don't have young icons like themselves, like this. Unfortunately, they have this guy, and he's a Scientologist. Darwin wasn't like this when he did it, when he created this wonderful book which changed our perception of ourselves and the world. This was young Charlie. He was 24. Maxwell wasn't like this when he developed the most brilliant advance of the 19th century of any field. It was wee Jamie with a little quiff on the top of his head, all right? Chandrasekhar, he was a young man when he presented, he was an undergraduate when he created this formula which showed that a star about 1.5 times the size of the sun would collapse into a black hole. And he wasn't appreciated. These are the young people. I don't have a picture of this guy, one of my heroes. He did all the experiments on penicillin. Nobody's heard of him. It's Norman Heatley. This is a picture supposed to be me of the newspapers, right? A student wrote, "Fantastic likeness, Harry," on the side. It was put up. I made him do an extra year for his PhD for writing that. Jim Heath and Sean O'Brien and Yuan Liu and Jonathan Hare helped us with the discovery of C60. We've got to recognize that we've got to do something. And so I set up a global educational outreach initiative. It started off with the Vega Science Trust, okay? A fantastic site. 75 of those programs were shown on the BBC. I'm now involved in something else. And I want to show you this because things have changed. How many of you have looked at an encyclopedia this year? How many of you looked at Google this week? How many Wikipedia this week? How many looked at YouTube? Okay. This is a picture in Encyclopedia Britannica, all right? Now, we're in what I call the GUE wiki world. Google, YouTube, and Microsoft and Wikipedia, they've actually changed our world. Look at this image. This is in Encyclopedia Britannica, all right? Now, if I go to Google and search on the image browser, all right, what I get is pages and 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 even rotating images. We can't look at that and not say something has changed. And it's a massive revolution. Google is a paradigm shift in seeking, finding, and accessing information. Embedded information. YouTube. Kids are making their own films. TV and films in Hollywood are no longer in control. Microsoft has spearheaded, with Apple and others, the sort of universal compatibility of digital applications. And Wikipedia, probably more than anything, has shown that individuals with a passion for whatever it is they're interested in can make that knowledge available. All that is fantastic. And we can use it to create a cache of URL links with teachers and universities throughout the world. So I call it GYW 2.0. And what is it? Well, I want to get to every teacher in the world. There's a satellite dish on this mud hut in Kenya. And here is the teacher. If they can get television into that village, we can surely get the internet into every school to help that teacher and use the teachers that are there. We're not going to change the number of teachers or science teachers anytime soon. So we must help them to actually make sure they have access to the best scientific material and the best material of any kind. And I set up GEOSET, Global Educational Outreach for Science, Engineering, and Technology. So what is it? Well, basically, it's this. It uses capture station technology, very similar to what we have here. It's the future of broadcasting. And it has a double image. Here is the video, and here is the downloadable data. So the teacher can download my presentation or the presentation from some fantastic teacher in Japan or in South Africa or in India or the USA or Europe, okay? And they can just take it and download it. And we're getting help from Microsoft to make that inexpensive. I want to show you just one of the things. We can get young people to do the work. Believe it or not, they're fantastic. I want to show you one of my favorites. And this is by a student at...
Recently, the first case of inbreeding that was scientifically linked to deformities in animals was released. This study was done by John Vuccetti and Ralph Peterson with the School of Environmental Science at Michigan Technology University on a population of wolves, a very close relative of the dog. The study was conducted on a small, isolated wolf population located at Isle Royale National Park.
Let me stop there. This is an amazing study. 70 years ago, an ice bridge formed between Canada and the States onto an island. This ice bridge has never formed again. A pack of wolves got isolated on this island, and all the wolves now, today, are related to one female and about 2 or 3 males. It's an amazing 70-year-old study of inbreeding. I'll just jump on because I want to show you basically because we don't have too much time, and I want to show you this.
This graph shows the vertebrae defects in relation to the estimated birth date of the wolf. The number of deformities seems to increase significantly during the late 1980s. Vuccetti and Peterson noted that for the last 12 years, every one of the wolves they found dead had some sort of bone deformation. The photograph on the left-hand side is what a normal wolf vertebrae should look like. And this photograph on the right is the defected vertebrae. Again, in this photograph, you can clearly compare and contrast the deformed vertebrae versus the one on the right, which is the normal vertebrae, or the one on the left, which is the normal vertebrae. I realize that probably not that many people are interested in conservation biology, but where this subject hits home to many is in their puppy dogs.
Let me stop it there. This is her CV. She's going to get into vet school. She's found a fascinating thing, and she's making it available. We're using now young students who are undergraduates to sift out the things that they're interested in. They don't, in general, need to be particularly experienced teachers. And so I wanted you to think that the internet there is something that can really help teaching really very well. Okay. I've got Vincent has done one on beetles. Kerry has done one on organic chemistry and on invisible ink. In fact, I show you now how I assess my students. Many of you have done some marking if you're involved in teaching. You know what it is. Sunday, the last thing you want to do is go through this pile of paper, all right? But by watching, I can watch these and enjoy the presentation of the students. And here I am in England watching my students in America and assessing them. I don't even need to be there. I've done workshops to Iceland. Okay, this is one, I would have loved to go to Iceland, but I just couldn't go. Okay? In fact, I did 3 last week. I was coming here, and 3 of them, one to India, one to St. Petersburg in Florida, and another one to Italy. Okay? So this is the situation. I teach kids algebra and maps, for instance. This is a little one for young children about maps. What did Mercator do? He took an orange, cut it up, cut it long, opened it up, ate the fruit, flattened it out, and ended up with the orange peel map of the world. That's where it comes from. And so we're creating little presentations for teachers wherever they are. The network is growing. We've got links now to Australia, to New Zealand, to the UK, to Japan, as well as other places in the USA. Come to the last few things I want to say. Feynman said the freedom to doubt is an important matter in the sciences, and I believe in other fields. It's from the meaning of it all. It was born out of a struggle. It was a struggle to be permitted to doubt, to be unsure. And I do not want to forget the importance of that struggle and by default let it fall away. If you know you're unsure, you have a chance to change the situation. That's vital. I want to demand this freedom for future generations. I think that's rather good. Walt Whitman, the great American writer, says, I like the scientific spirit, the holding off, the being sure, but not too sure, the willingness to surrender ideas when the evidence is against them. This is ultimately fine. It keeps the way beyond open. That's the most important aspect of science. Saving the planet, it's a global citizenship project. We've got to work. We can't do it alone. We've got to make sure that we work together. The arts and the sciences must join forces. Many of you know where this comes from. Of course, Guernica, the most amazing painting of the 20th century. I'm not Picasso's greatest fan. I like to be able to recognize the women when I see them, okay? But this is an amazing picture. The pain and anguish of a mother whose child is dead. Scream of someone dying, dead people, horse with a spear in it. This great painting is now back in Spain. The lesson is interesting. On the second floor of the United Nations, there's a copy of this 20th century artwork that offers a graphic and chilling reminder of the horrors of war. Profound symbolism as the UN hides Picasso's anti-war masterpiece for Colin Powell's UN address prior to the invasion of Iraq. That is interesting. The power of art is very interesting, and how politicians can fear it. Science, well, evolution teaches us that survival is our destiny, and critical analysis, e.g. science, thus indicates that we need to foster humanitarian attitudes to further this goal. Thus, contrary to the claims of many who are anti-science, science does provide a spiritual and ethical guideline, not to kill each other, but to cooperate with one another, as well as the natural world, for the survival of the human race as well as our cousins in nature. I'm involved with a number of organizations. One is INES, the International Network of Engineers and Scientists for Global Responsibility. I don't want young kids to go into physics and make more effective atomic bombs. I don't want them to go into chemistry to make a more effective napalm. I don't want them to go become an engineer to make more effective landmines. Go to Google and watch something like Soccer in Sierra Leone or whatever, and you'll see a film of a little kid with one leg the other blown off by a landmine, playing soccer with on crutches and dreaming of getting to the paraplegic Olympic Games. Society can use science either for the benefit of mankind or for the detriment of it. And we've now got to recognize we're on a threshold. As Einstein said, when we invented the atomic bomb, we can kill not just a few people, but a whole city. The greatest man I knew personally was a physicist, Joseph Rotblat. This is a picture of him. I got to know him very well in the last few years of his life. We became very close friends. He was the only scientist, or maybe there was one other, who left the atomic bomb project in Los Alamos when it was clear that the bomb was not necessary and it had still not been completed. Unfortunately, all the other scientists stayed and finished the job off. In his Nobel address, he made an impassioned statement. We appeal as human beings to human beings. Remember your humanity and forget the rest. If you can do so, the way lies open to a new paradise. If you cannot, there lies before you the risk of universal death. The quest for a war-free world has a basic purpose, survival. But if in the process we learn to achieve it by love rather than by fear, by kindness rather than by compulsion, if in the process we learn to combine the essential with the enjoyable, the expedient with the benevolent, the practical with the beautiful, this will be an extra incentive to embark on this great task. Above all, remember your humanity. Here is Joe, a couple of years before he died, at the age of 97. He was a wonderful man. He got the Peace Prize. He was a fantastic physicist, and I can prove that too. Nobel Peace Prize with pugwash. And here, look at this. I'm sure that's defying gravity. I can't understand how those books are staying up there. And there's a picture of me in front of a picture of me in front of a picture of Joe in the Einstein Cafe in Berlin. Remember your humanity and forget the rest. The last two slides. This is my favorite poster. I just love it. I'm an alien creature. I was sent from another planet with a message of goodwill from my people. The message says, Dear Earth people, when you finally at last destroy your planet and have no place to live, you can come and live with us. And we will teach you how to live in peace and harmony, and we will give you a coupon good for 10% off all deep dish pizzas too. Sincerely, Bob. Well, why do I lie? Well, destroy your planet. Well, I'm a scientist. Depends on the day. I go between 70 and 80 and 90% sure we're destroying our planet. I'm 70 to 80% sure. I'm not too sure. I'm not completely sure that we're responsible. We've got a big problem on our hands. And a scientist, when he says those, he said, I'm not sure, but it looks bad. Let's err on the side of caution and do something about it. The second thing, peace and harmony. Is it not incredible that in the 21st century, democracy or whatever we have to elect our leaders cannot elect leaders who can sit down with the others and solve our problems without sending young people to kill each other? When you stand back from that, it is unbelievable. Unbelievable. But at the end of the day, Stein's got a sense of humor. Without that, I don't think life is worth living. And so I'll come to my bit of film that I love more than anything else. It's from Mexico.
I walk the maze of moments, but everywhere I turn to begins a new beginning, but never finds a finish. I walk to the horizon, and there I find another. It all seems so surprising, and then I find that I know. You go there, you go forever. I go there, and it's forever. We stay without you, anywhere. The moon upon the ocean is swept around in motion.
Now, I never cease to enjoy watching that, because those are our future. And I can't help thinking that if the people who run our sort of businesses and run our society had decided that the main thing that they should think about is what is best for the future of those kids, then we wouldn't be in the economic mess we now are in. Thank you very much.